I'm Anil Kumar, and in this series, we have seen a couple of examples which help us write equation for the given graph. Now, most of the graphs are for sinusoidal function, so we are in a position to write different kinds of equations using sine and cosine. Now, I'll request you to take this particular question as your test question. You can pause the video, look at the graph, and then find the equation for this graph in terms of sine and cosine. What I'm trying to say is, you give me equations like y equals to a cos k x minus b plus q, or you can write an equation as a sine, and x minus b plus q, right? You can work in degrees or in radians, right? Once you get your answer, then check with my solution. In this video, I'll teach you how to write equation in both degrees and radians from the given graph, right? So let's begin by reading the values straight away from the graph. Now, easy values to read is maximum and minimum. So from the graph, we say maximum is 3 for us, minimum is -1, correct? So this is 3 maximum, minimum is -1. So that gives us the value for A and D, right? So as you know, A, the amplitude, is difference of these two values divided by 2, is actually maximum minus minimum divided by 2. So in our case, it is 3 minus -1 divided by 2. And that gives us a value of 3 plus 1 divided by 2, or 4 divided by 2 is 2. So the amplitude is 2. Now let us find the axis Q in this case, right? So Q equals to average value. Average is you add them up and then divide by 2. So when you add them up, what do you get? You get 2 divided by 2 as 1. So as soon as you get axis, better it is for you to draw the axis. That gives you a fairly good idea, and it's a check for you at this moment. So this is the axis for us, which is at 1, and then check whether you got the right amplitude or not. So if you go up from the axis, you are going 2 units up, that is correct, and 2 units down, perfect. So that is just the right answer, right? So it is the first check which should be performed. Now we have got all this. We are looking for inside parameters. They are relating to horizontal things, right? So K is related to time period, which you can calculate from either two maximums in this case, or between two minimums, whatever is convenient to you, right? So time period is the horizontal distance for one cycle. Now cycle repeats. If you start from maximum, it repeats at the next maximum, correct? Therefore, two maximums or two minimums are good points to check. Now if I start from this maximum, what do we get? We get 1, 2, 3, 4, 5, 6, 7, 8 units. And the scale is 1, 2, 3, 4 units is 1, 8 units is 2. So the time period is 2 for us. So what we get from here is, let me write down here itself, time period of 2 units, whatever it could be, right? Now that time period helps us to find the K value. So K basically is 360 degrees divided by time period T. If you are working in degrees, so that gives you 360 by 2 or 180. But if you are working in radians, then one full circle is 2 pi radians. So in that case, K will be 2 pi divided by 2, and that is pi, correct? Pi is equals to 180 degrees. So that way is also you could immediately, translate or change the units. Got it. So we know the value of K now. Let us now figure out P, the phase shift, that is critical and very specific to the parent function. If cosine is your parent function, so how does cosine look? Let's make one cosine graph. It is kind of like this, right? Cosine starts with maximum. So what we need is, we need to see from where the cosine graph starts. So that is the first maximum for us. So it starts from here. How many units away from origin? 1, 2, 3 units away. 3 means, in this case, 1/3, correct? So we have P as equal to, it is 0.75, right? It is 0.75, I should say, 0.75, or these are all 1/4, 3/4. Either way you could do, right? So I'm taking P as 3/4 for the cosine wave. So if I do that, then I can write my cosine function as, so let me write it big and bold right here. So y equals to A is 2 for us, right? Cos K is in degrees 180. Let me write degrees first, right? And then x-axis, phase shift of 3/4 to the right, so minus 3/4, plus the q value, which is at 1. Got it. So that is how you can get this equation. In radians, you could write this as cos, just change it to pi, right? And x minus 3/4. Now, okay, and then plus 1. So you get your answer. That is it, right? Now, let us see how to write equation for the sine graph. Now, sine wave actually starts from the axis, kind of like this. Do you see that? That is a sine wave. So you're looking for a point which starts from the axis and it is rising. So if you look here, that is the point, starting from the axis and rising. And it is 1/4 of the unit to the right. So in this case, P is equals to 1/4, okay? Now we'll use this value as a phase shift and write equation for the sine graph, okay? Now, sine graph could be written as, the equation of the graph in sine as a function, okay, is y equals to, rest all remains same, 2 sine 180 degrees x minus 1/4. Do you see that? Plus 1, or in degrees, in radians, you could write as 2 sine, okay, pi x minus 1/4 plus 1, correct? So that is how you can actually write the equation from the given graph. Whether you're doing it in degrees or in radians, the concept is same. Read the maximum minimum values, find A, the amplitude, Q, the axis. Then read the time period, find K, the number of cycles in one full circle, which will be 360 degrees in degrees and 2 pi radians in radians, one full circle, right? Once you get that, then check for the cosine and the sine function. Starting point for cosine should be a maximum. Starting point for sine is value on the axis rising up, right? So find the axis rising up, not rising down, not this point. That will be negative sign. Be careful. And then substitute the values in the general equation to get both the correct equations. I hope that helps. Thank you and all the best.